yesterday we were looking at trying to take a set of points that we have and create an equation. Even if we don't have a graph, we don't necessarily have a graph. I'm going to be showing you some graphs later on and getting you to put equations on them. But what if you don't have a graph? What if all you do is you have a bunch of data that was collected? You know, you went out into the real world and you collected some data, and the theory is that you can match a trigonometric function, what's called a sinusoidal function, to this. What would that function look like? And of course, you could use that function to make predictions based on how that model would, the word that you might remember this word from your grade 9, interpolation and extrapolation. You can extrapolate from that model into the future. Well, here's where we got yesterday. You hopefully remember this. We had the wheel spinning in the water, and there's a certain point on that wheel, I'm pointing to it right now, that as the wheel turns, it would either be below the surface of the water or above the surface of the water. And the height either above or below the water is what the h represents in this table. So when it's negative, it means it's below the water. So, okay, we did this. We figured out the A, we figured out the C, we figured out the period, figured out the K from that, figured out the phase shift. Then we, using all of that information, came up with a cosine function, which was this function I'm pointing to right now. And we also said that this function could be changed into, because it's a cosine function, into a sine function by taking a quarter of the period of 60 seconds, dividing it by 4, and adding that onto this phase shift, and that will give us a sine function phase shift. So we can use either of these two equations to generate this table of values, right? I could right now put any of the x values in from this table and get something which is pretty close to the y value. So one of the questions that I wanted us to answer, and one of the questions is pretty easy. It says, what would the height be after 97 seconds? Well, I'm not going to do that because that's too easy. That's just plugging 97 seconds into the function. What I would like us to do is to try part D, because that involves a lot more work. After how many seconds would the paddle reach 1 meter above the surface? I asked that question yesterday. And the answer I got was that we'd have to set this thing equal to 1. We'll take the sine version of the equation. It doesn't matter. We could have used the sine or the cosine. But I'm going to go with the sine version of the equation. So let's do that exactly. Let's take this equation, set it equal to 1, right? So 1.395, 1.395 sine pi over 30 x minus 20 minus 0.005 equals 1. Okay? So what does the question ask? Quinn is asking. Okay, let me go back and show you. Question says, after how many seconds would the paddle reach a height of 1 above the surface? Okay, Quinn? So that means that we should be using a positive 1. If it had said 1 below the surface, then I'd have used negative 1. But because it says above the surface, I'm using positive 1. And I'm setting the equation because that's the height. This equation that we have here is a height equation. So I'm taking this and setting, or well, I have y here, but this should have really been the height. The height is equal to all of this thing here. Okay? So Quinn, that answers your question, hopefully. All right, what does the question ask? Okay, good. All right, so how do we figure this out? How do we solve for the x? Well, we've done this kind of thing before. So walk me through the steps now, please, anybody. So 1.395 sine pi over 30 x minus 20 minus 0.005 is equal to 1. What comes next if I'm trying to solve for x? I just thought it would be a good idea for us to finish this question and get the practice in solving this kind of equation. Move the 0.05 over, absolutely, so we'll do that. So 1.395, the sine of pi over 30, x minus 20 is equal to 1.005. I just simply added that minus 1.005 to the right-hand side. Thank you, Hussein, and thank you, Quinn. Okay, so what happens next? Come on, walk me through that. We've done this before. Then divide both sides by the 1.395. Thank you, Brendan. So the sine of the pi over 30 x minus 20 is equal to the 1.005 divided by the 1.395. Okay, good stuff. Keep going, folks. Keep going. Remind me of the next step. Everybody should be engaged at this point and sort of coming up with their own ideas as to what happens next. What's next? The sine of something is equal to something else. 1.005 divided by 1.395. What do we do now? What's next? Nobody remembers the next step. Kind of important that we remember this, right? I want to get that x. I want to solve for x. So can somebody tell me how to get that x? Take the sine inverse. Thank you. Thank you, Roma. Thank you, Hussein. So we're going to say that this thing that's left behind, so this thing I want to underline here, right? This part here, right, is going to be what's left behind after I take the sine inverse. So the pi over 30, x minus 20 is equal to the sine minus 1 of 1.005 over 1.395. Okay? Now, I like to call this thing prime, right? That's just my way of doing it. You don't have to follow that, but I'm just saying that's my way of doing it. And what I need one of you to help me out with now, and let me go to my list here. And I'm going to ask if I could ask, let's see, Hunayin. Hunayin, can I ask you to tell me what sine to the minus 1 of 1.005 over 1.395 works out to be, please? What is that equal to? Hunayin, you're there, right? Perfect. Can you give me that number, please? So 1.005 over 1.395. What's the sine inverse of that? What was the question? All right. I'm asking you to calculate this. The thing I just underlined. That's the question. All right. And of course, that involves having to use a calculator. There is no getting around that. Give me that answer to 2 decimal places, please. Give me that answer to 2 decimal places. And everybody else should be doing this for themselves so that if for some reason his answer isn't right, we can correct it. Okay? So you all should have your scientific calculators close by. Shouldn't we make it 3 to be as in 3 decimal places, Brendan? Is that what you're saying? You know what? I think you're right. Because we are dealing with 3 decimal places in the question. I'm going to take your advice on that. Brendan is right. Let's keep it at 3 decimal places to be consistent. So back to Hunayin. Hunayin, I hope you have your calculator fingers working away on the. Okay, so 0.804, he says. Okay, so pi over 30 x minus 20 prime is equal to all of that. Now we have to ask the question of where to place this answer. Right? Thank you very much, Natasha. Thank you very much, Brendan and Lynette and Edmund and everybody else. All right. Sinduja, everybody chimed in there. That's great. Joshua, which quadrant should I be looking in? Joshua, you're there with us, right? Where's Joshua? Joshua, where are you, Joshua? Perfect. Can you tell me what quadrants I should put this angle in, please? What quadrants make sense to you? Considering that we're dealing with sine, and ask yourself, should this have been a positive number for sine or a negative number for sine? You tell me, and then tell me what quadrants to put these angles in. The 0.804. If you're not sure what I'm asking, then please ask me for help. But I'm asking you for an answer. What quadrant should I place my 0.804 in based on the calculation we just did? The first, only the first? Any other? Is there any other quadrant, Joshua? And the second. Okay, good. So remember, in both cases, is 0.804 from the x-axis. Now, the truth is that we have to accept that this wheel is going to be at 1 meter several times. Perhaps the question should have said, and maybe I should have rephrased the question that way, is when is the first time it's going to hit that 1 meter mark? So it would suggest that we should just take the first time, which would probably be the 0.804 here. So let's go with the 0.804 answer and work from there. All right, so we're going to say that we don't need a prime anymore. We're going to say that the pi over 30 x minus 20 is equal to 0.804 using the first quadrant as our answer. Okay? Okay, let's see what's going on here now. Yes for sign. Okay, when it's negative, it's in the third and fourth, right? Are there any exceptions? So, Joshua, you asked the question, and Chrisania just answered that for you. Thank you, Chrisania. I should turn the class over to some of you guys sometimes. I think you probably teach this better than I do. Okay, so anyway, let's keep this going. We haven't solved for x yet, and I think it's important that we get that skill. Jenna, can I get you to help me out now, please? What would you suggest I do next? Right? I'm trying to solve for x. Jenna, are you there? Perfect. Can you give me a step that would make sense to you right now? What do you think is the next possible step that would make sense? Don't we need to bring the pi over 30? If not, why don't we bring the pi to the left side of the equation? Put the pi over 30 on the other side. So tell me exactly what to write then. Right? I want to make sure I follow what you're saying by saying put the pi over 30 on the right. Tell me exactly what I should write. What should I put on the left side? What should I put on the right side? I want to be specific. Mm-hmm, mm-hmm. Okay, good. So what's left on the left side then is what I'm asking because I want to know what to write down. Okay, good. And what's going to be on the right side? Good. But there's another way that we've been doing this. Thank you, Jenna. That's good. Does anybody thank you? That's actually is right. So is there a way that we can divide by pi over 30? Does anybody remember what we did? Multiply by the reciprocal. Exactly. So what we're going to do is we're going to multiply this by the reciprocal of pi over 30, which is 30 over pi. That's the very strange looking pi. Let's fix that. Okay. All right. So let's see whose hand is that. Lynette, please go ahead. Pi. No. It's because okay. Let me repeat your question. Does it matter if we divide it by pi over 30 or multiply by 30 over pi? Both operations are identical. So to me, it's really just whether you want to. I mean, I'm trying to find an analogy for that. But to answer your question, Lynette, the truth is that both ways will give you the same answer. So it doesn't really matter. All right. Okay. So I'm going to need some help on this because I cannot do this in my head. I'm going to ask one of you, let's see, Mohammed. Mohammed, can you multiply that for us, please? 0.804 times the 30 over pi. Mohammed, are you there? Okay, could you do that part for us, please? Give us 3 decimal places. Let's be consistent. Give us 3 decimal places for that. And of course, that's x minus 20. That's equal to all of that. And we're just waiting for Mohammed's answer. Hopefully he has his calculator close by. Because everybody's supposed to have their calculator close by. Okay, good. Let's get the answer then. And of course, I know everybody's standing by, ready to declare you right or wrong. So let's see if you get it right. Okay, so he's getting 7.677. 7.677. And I'm not going to insult you by asking what comes next. Clearly, we're just going to add 20 to the two sides. So 7.677 plus 20. So we're saying it's approximately 27 point. We'll round it at this point to one decimal place. X equals. Okay. Yes, Chrisania, please go ahead. Uh-huh. Oh, okay. You know what? If you say it, I'll put the 8 in. But I did round it anyway, so at the end of it, it's still going to be 27.7. Can I get some units now for this, please? What would you suggest would be the proper units without me even going back to the question? Think about what the question was asking. Seconds is correct. Yes. So whenever you have a word question like this, just FYI, I'm expecting, for your information, I'm expecting at the end of that, whoa, that's a long thing, long answer. After how many seconds would the paddle reach a height of? I'd expect a statement answer. So I'm going to put a statement answer there. It would take 27.7 seconds. Okay, I'll just put that as short for seconds. Okay, thank you very much, Brandon. Thank you very much for saying. You all chimed in there, gave me the correct units for that question. Okay, so there's another two parts of the question which I didn't really tackle and just mention them. What's the diameter of the wheel? We have enough information to know the diameter of the wheel. If this, what is this that we're looking at here? The paddle. If this paddle is right on the edge of the wheel, right? We have enough information from the question to figure out the diameter of the wheel. And I'll just tell you, without me spending a lot of time on this, what that would be. We can look at what the lowest point of the paddle is and the highest point of the paddle is, and the distance from the high to the low would obviously be the diameter of this wheel, right? And we had the high as being 1.39, the low was minus 1.4. So whatever that distance is, that would be the diameter of the wheel. Okay, so I'll just mention that. And we didn't do part C because I thought part C was just way too easy. What's the height of the paddle after 97 seconds? Let's put 97 into the original function. Why didn't we calculate the second quadrant? Hussein, that's a very good question. I'll just read Hussein's question. Why didn't we calculate for the second quadrant? And Quinn is asking the same question. Let's just think about this for a second. Let me open up another thing here. Let me put a circle here. Right? So if I have, let's say the center of the circle is somewhere around here. If I have something, let's say the 1 meter mark is, I'm going to put a line in for that 1 meter mark. Let's say this distance here is 1 meter above the surface. Well, as this thing turns, there's going to be several times, if let's say the starting point was somewhere, let's say this here was the surface of the water. Let's just use that as the surface of the water. As this thing turns, let's say it's turning in a clockwise direction this way. As this thing turns, let's say that this is the first time it hits the 1 meter mark, 27 seconds right there. Can we agree that as you continue turning, it's going to hit the 27-second mark again? This would probably be the second quadrant answer. It's going to go below. Somebody has their mic on. If you could just mute it for me, apart from me. Could you just mute it for me, please? So the answer that we got was probably the first time it hit the 1 meter mark. But if the question only asked us for the first time, which it doesn't specifically say the first time, but we probably should just give the first time that it reached the 1 meter mark. But it's going to keep hitting that 1 meter mark, right? It's a wheel that's turning, so it's going to hit the 1 meter mark several times. That's why it's sinusoidal. It's going to keep going up and down, up and down, up and down, hitting that 1 meter mark several times. Okay, so why didn't we calculate the second quadrant? We could have. The second quadrant would have probably been the second time on its way down. So if we were turning On its way up, it's going to hit the 1 meter mark. On its way down, it's going to hit the 1 meter mark again. And it's going to do that again on its second cycle, and so on and so forth. Is there a summative graph for this unit? I haven't quite decided yet. There's an old one that's there right now, but let me just take some time to think about that as to how we're going to do that assessment for this unit over the weekend. Okay. All right. So is it optional to calculate the second quadrant? Let me say, okay, you know what? I'm happy you're asking these questions. If the question said, give the first 2 times that the height of the paddle was 1 meter, then I would include the first and second quadrant. Does that make sense, Hussein? Right? Because it's going to hit it several times. So I guess it just depends on the way the question asks it, right? It's not just the first time it's going to hit the 1 meter mark. It's going to do it on its way down. When it circles and comes back again, hit the 1 meter mark again, and so on and so forth. Okay, so thank you for the question. Hopefully that answers it. Okay, now let us move on to some graphs. Here's where you are going to be. I'm going to skip. I had this question picked out for you at one point, but because you did some lessons with homework already, I'm just going to skip it. We're going to show you a couple of graphs, starting off with this one. I want everybody right now, analyze this graph. I want both, and I'm going to give you some time to do it. I want both a sine and a cosine equation for this graph, right? So you figure out what the A is, you figure out what the C is, you figure out what the period of the function is, you figure out what the phase shift is. I'm going to recommend, and you don't have to go with my recommendation, that you write it as a cosine function first, and then take the cosine function and then also write it as a sine function after that. Or if you prefer to write the sine function first, that's fine. It's 2 o'clock and Hussein is the lucky winner of the draw. So Hussein, let me first of all make this a little smaller so that I can write your equation underneath the graph. And you can decide whether you want to give me a sine function or a cosine function. So, let me take Hussein out of the wheel in the meantime. Okay. So, Hussein, what do you have for us? You ready for us? I will start with cosine. Okay. So, y equals, I'm ready to write. Let me put it in black. So, y equals, and of course, we get some opinions on this after we have written the equation. And I'm going to be asking the next person for the sine version of this equation. Remember, I want both sine and cosine. So since Hussein is starting with cosine, the next person would have to give us the sine. I find the cosine to be easier. I'm going to write down exactly what he says. So 4 cosine pi over 4, and then x minus 5, close bracket, minus 1. You might be wrong. All right. There's always that possibility. We all make mistakes. But let's just check in with the room on what Hussein said. So Hussein is expressing some doubts about his answer. What do other people think? Is Hussein... Okay, Quinn says nope. Okay. So we got one thumbs down on that. Oh, bang on. So I'm not sure what Quinn is saying. Is Quinn saying yes or no? Oh, I got you. I got you. I got you. Okay. So let's see. Brandon is with you. Brendan is with you. Alexa, Hussein. Okay, Hussein's got a lot of love here. Okay. Let's say if anybody disagrees. I don't see anybody. Brandon, Brendan, Alexa. Don't know how to get the period. Agree to. Okay, so okay, great. All right. So a lot of people are on your side there, Hussein. We'll get to the cosine in a minute, but let's just sort of analyze this function and make sure, Sindhuja, don't know how to get, okay, so we'll try to help you with all of that. First thing is, what's the amplitude? Well, to get the amplitude, we take the high, which is 3, right? We minus the low, which is minus 5, and take that result and divide it by 2. So in this case, that's 8 over 2, which is the 4. So that's perfect. That's fine. Then to get the number on the end, we add those numbers together. So the 3 plus the minus 5 also divided by 2. Well, that's minus 2 divided by 2, which is minus 1. The other thing that's useful for you to do is to put that center line in. You've heard me talk about that before, so I'm going to do that right now. That center line at minus 1, that could actually help you with some other parts of this. So there's my center line. Okay? The next thing we had to figure out was the period. Now, let me sort of help you with that. One of the ways to get the period is to subtract two highs or two lows from each other. Okay? So one high occurs at, I'll circle it. One high occurs at, let me put it in green, at minus 3. The next high occurs at 5. Right? One of the things I also said to you yesterday is that if you have a table of values and you don't have two highs in the table of values, take a high and a low, find that distance, and then multiply it by 2. But we do have two highs here, right? So how do I go from minus 3? Remember, when you're trying to get the amplitude, you're measuring vertically, right? Top to bottom. When you're trying to get the period, you're measuring horizontally from one peak to another peak or from one low to another low. That's how you measure the period. So how far is minus 3 from 5? If I put that on a number line, how far apart are those two numbers? To go from minus 3 on a number line to get to 5, how far is that? What distance is that? Right? Think about minus 3, think about 5. Okay, you put minus 8. Just think of it as being a distance of 8. I wouldn't call it minus. Okay, Sindusha? It's just a distance of 8. So to go from minus 3 to 8, I have to travel 8 to get from one to the other. But I also said that I could take the distance between a high and a low. So I could take the distance from the minus 3 to the 1, which is a distance of 4, then double that. So if I have a high and a low, I can take that distance and double it. Okay, so in this case, it was 8. So the period was equal to 8. So the K, so the K is equal to 2 pi, is equal to 8, is equal to 2 pi over 8, which is pi over 4, which is exactly what that person had, which is exactly what Hussein has. And then I said, okay, and somebody was asking, I think it was Sinduja, I think it was, I don't know who it was, how do we get the phase shift? Well, the phase shift is how far that, if it's for cosine that is, how far is the cosine high, how far is the high from the y-axis? We'll have to go all the way across to 5 to get to that. So that would make that the phase shift. And that's why it has x minus 5 here. He could have put x plus 3 because you can get to the other high by going to the left by 3. So I could have put x plus 3. That works as well. All right. So again, there's not just one way to write an equation. You can write it more than one way. All right. Let's see. Whose question is that coming up? Yes, Donna, please go ahead. Yep. No, okay, don't even look at it that way. Look at it as just a distance between two numbers. Think of a number line, right? If I put you at minus 3 on a number line and your friend was at 5 on that number line, how far apart are you? Think about it that way, right? Just that distance, because the period is really like a distance horizontally, right? The amplitude is really like a distance vertically. Really, think of it just as a distance, okay? Exactly. Exactly. Okay, you're welcome. All right. Okay. So where was I? Where was I? So we have that part. No. So the last part of that was getting the phase shift, which was 5, and that's why his function is what we see here. 4 cosine pi over 4 x minus 5 minus 1. No, I'm going to go spin my wheel again. And I don't know if this is the harder part or the easier part. I'm about to ask somebody to give me the sine version of this equation. Okay? And whoever comes up, I'm going to ask that person, right? And the wheel says Ryan. The wheel has spoken. Ryan, where are you? Perfect. Ryan, you have you have a sine equation you can share with us, please. I don't know if it's the easier part or the harder part. I don't know. What is the sine version of this equation? Okay, Brendan. The sine version of the equation, Ryan. And again, if you need help, you need to ask. And everybody else should be able to chime in and tell us whether the equation makes sense that he's about to give us. Sorry, could you explain the phase shift for the cosine? Yes, Davina. Okay, so let me go back to the picture. Just look for where the high is. See this green circle that I'm pointing to right now? That's the high, isn't it, on the cosine function, Davina? Okay, how far is that away from the y-axis? That's your phase shift for a cosine function. I want to stress that for a cosine function. Okay, all right. So waiting on Ryan now to give us that sine function, the sine version of the equation. So Ryan says for sine, I'll write that down. So y equals, put that in black actually, and we'll get some viewpoints on that in a minute. For sine, still pi over 4, but now he says x minus 3 minus 1. Okay, well, let's see, Ryan, whether people are going to be in your corner or not. What do you say to Ryan's answer? Alexa, wow, look at that, Ryan. Look at that. Lynette, Chrisania, Hussein, Kelvin, Roma, Alexa, they're all saying thumbs up to you on that. And you're right, right? What you had to do was to find the period, which was 8. We got that from before. Divide that by 4, which is 2. Add that to the original x minus 5, and x minus 5 plus 2, of course, gives you x minus 3. I could actually look at the graph and see that that's the phase shift as well. I put the center line in, and one of the ways you can get that phase shift is by looking at where the graph intersects with the center line. So here's one spot where it intersects the center line on its way up, and that's 3 to the right. So it's consistent with what we know about center lines and sine functions, not cosine functions, but sine functions. Okay? All right. That's good, Ryan, and that's good. I think it was Hussein before that. Here comes graph number 2. And you're going to see a difference in the way that this one's x-axis is scaled. Notice that the x-axis here is in terms of radians. Something like this will be on the test, right? I guess you'll find out on the 19th, right? Not going to give anything away, right? Just be prepared. That's all I'm saying. Just be ready for anything that Mr. Kama comes up with on the 19th. All right. Anyway, let's get back to this. The scale is different from the one we had before. This scale is in terms of pi, and you need to be able to write a function which has a pi scale. So the one before that wasn't a pi scale, just a 1, 2, 3, 4 scale. This one is a radian scale, but the principle and the process is the same. Okay, the way in which you go about getting the amplitude and the vertical translation and the phase shift and the period, those are not changing. Do I mind zooming in, please? I certainly can. I certainly can. Okay, there you go. Let us talk about this. I'm going to sort of make the view a little bit smaller because I need to be able to write the equation under it. All right, so Sinduja, you win the prize, the wheel prize. Are you ready with a cosine? Well, I mean, you decide which one you want to give us. Do you want to give us the cosine or do you want to give us the sine? Sinduja, you're up next. Are you there? Sinduja, are you with? Okay. Oh, look, she has something ready to go. Let me write down exactly. I'm just going to write it down. Not saying, I'm not making any comments yet. Just going to write down what you said. So y equals 6 cosine bracket 8 pi over 3. 8 pi over 3 x minus 5 and plus 1. Okay. All right, so let's get some comments from the room. What do other people think? I'm not going to give any indication of whether I agree with it or not. What do people think? Let me get some feedback on that from the rest of the room. Anybody going to say yes or no to that? Chrisania is not sure. Did not get that. Quinn says, I got something different. Disagree. All right, let's do this. Let's do this in stages. Okay, so nobody's okay. All right, that's okay. Let's do it in stages. How about the amplitude? Is the amplitude okay? Let's start with that. Are we going to agree with the amplitude? Okay, so Sinduja, so far the amplitude gets a thumbs up. How about the vertical translation? Is that part okay? Vertical translation, that looks like that gets a thumbs up as well. So it looks like we're okay with this part and this part. Looks like we're okay with those two things. That's what it sounds like to me. What may not be so okay is the K value. All right. So why don't we do this, Sinduja? Let's come back to you a minute on this. So Sinduja, are you with us? Let's see if we can get everybody else to agree with what you have. All right, let's talk about the period of this function. Tell me how you got the period that you got. Not the K value, we'll get to the K value later on. How did you get the period of the function? What did you think the period of the function was? And then tell us you thought it was, yup, so okay, I'm not following what you're saying. Clarify that for me, please. What's the period of the function? And we can talk about how to get it if you're not sure, but let me hear what you thought it was first. Pi over 6 minus 5 pi over 6. Okay, so let's do that. Let's do that. Because I agree with that, by the way. So let's do it the other way around. Let's so it can be positive. So 5 pi over 6 minus pi over 6. Okay, so hold on, hang on a second. So what is that result, by the way, first of all? 5 pi over 6 minus pi over 6. What is that? So that would be 2 pi over 3, okay, or 4 pi over 6, which is equal to 2 pi over 3. I agree. Okay, so how do you work out your K value again? So by the way, I think everybody agrees with you on that. I think so. I hope so anyway, because you're right. 2 pi over 3 is a period of the function. So how do we go from that to the K value again? You remember how to get the K value? How do you get the K value again? Because I see where you're saying you add, no. I remind you then, the K value is equal to 2 pi divided by the period. Okay? Got to remember that. It's 2 pi divided by the period. So in our case, it'll be 2 pi over 2 pi over 3. All right? Now, how would I do this part, Sinduja? I'm going to stick with you on that. How do I take 2 pi and divide it by 2 pi over 3? What's another way for me to say the same thing? I'm going to work with not just you, but everybody else who might not have got the right answer for that. How do I take 2 pi and divide it by 2 pi over 3? Reciprocal, good. So it's going to be 2 pi times what? What's the reciprocal? 3 over 2 pi, okay. So what's the result of this? So what's the K value then? Because that's what we need for the equation. It's 3. There you go. Now, can I get everybody else to give me, excuse me, everybody? Okay, great. So we'll go back. Thank you, Sindusha. We'll go back and make that little change there. All right, we'll go back and we'll come in here. I will change that to 3. No, actually, I should put that in black, shouldn't I? Let's be consistent. Let's change that to 3. Now, let's get to the phase shift now, Sindhuja. I'm going to come back up here. The phase shift for a cosine function, has to do with where the high is. Right, Sindhuja? Okay, how far is the high from the y-axis? How far do I have to go for that high? What does that say? 17? 7? No. Let me make it bigger for you. Maybe it's because my graph is not big enough for you. That's certainly possible. Okay, now tell me how far I had to go to get to that high. I'm not saying what is the high. The high is 7. Yeah, we get that. But how far along the x-axis do we go to get that high? That's what we're asking you, Sindhuja. The high may be 7, but where does that occur? Okay, I'm asking for the x value that gives you that high. Okay, I want the x value, the first x value. That's your phase shift. That is your phase shift. Okay, so that's what I'm going to do now. I'm going to put that in as my phase shift. So instead of -5, I'm going to erase that. I'm going to put in pi over 6. Okay, now did everybody else get something similar to that? Hall pass from Natasha. Okay, fine. And Hussein and whoa, Brendan and Alexa. Excellent. Is there anybody who needs me to go over any part of that again? And Sindhuja, does that make, don't want to give me, I'm going to take your question in a second. And Sindhuja, does that all make sense to you now? Because there's another one coming up. Okay, wait, can you quickly explain how to get the pi over 6 again? Okay, so do you see that the first high occurs right here? Can you see that, Edmond? All right, so that high is how far to the right? That's what I'm trying to ask you. How far to the right is that high? How far is it from the y-axis? Okay, does that make sense? And Lance, does that make sense as well? Okay. Okay, great. All right, so that was the cosine function. I'm going to remove Sindhuja, who is safe for today. All right, don't get too relaxed. Don't get too complacent. And the wheel is now going to be picking. Well, I actually asked that person for something earlier on. So I'm going to take. That was Jenna who the wheel picked, but I did ask Jenna for something earlier on. So I'll take you out for today, Jenna. I will take somebody else. We will take Alexander. Okay. Alexander, are you there? You are supposed to be there. Alexander, perfect. Okay. I hope you have a sine function ready for us. I'm going to erase all of this, right? So we need some space now for the sine version of the function. So I'm going to get rid of all of this here. Okay. And I'm going to come back up and ask you, can you give us a sine version of this function, please? Do you have one ready to go? If you need help, of course, as I always say, ask for it. But do you have an equation ready to go? Okay, here we go. So 6 sine 2x minus 1. 6 over, is that slash supposed to be there? Or I'm not sure. All right, I'm just going to write down what I think you have there. Y equals 6 sine, that looks like 2x minus 1. Okay. Do I have that right, Alexander? Do I have what? Do I have your equation right now? I just want to be sure. Okay, fine. So let's check in with the room and see if other people agree with you on that. Okay, nope, nope, nope. A lot of no's there. It doesn't sound that way, Alexander. So Alexander, you're gonna have to help. You're gonna have to work with me here. how do you go from a cosine equation to a sine equation? What's the strategy that we've been talking about? Right? I'm assuming you've been following along as we've been doing this, and we've done this a couple of times. So please tell me, how do you go from a cosine equation to a sine equation? What's the steps? Give me some steps here. Right? What have we done in the past? What did we just do 10 minutes ago to go from a cosine equation to a sine equation? Do you remember when we were doing this a few minutes ago, what the period was? When I was going through that with, was it Sinduja? I forget who it was. Sorry. Um, okay, so I'm sorry if I forget who it was. Do you remember what the period of this function was? Look at the function again. Do you remember what the period of this function was? We went through the process of calculating it. What was it again? So you're right. I agree with you. We need to find a period because, and I'll remind you, we need to find a quarter of that period. So what was the period, Alexander? It was pi over 6 minus 5 pi over 6. Good. And then when we reduced it down and everything, what do you remember what it was? Yeah, so finish that calculation, Alexander. Finish that. Do the calculation. You're right. So it's the pi over 6 minus the 5 pi over 6, which gives us what? Give it to us in its lowest terms, by the way. No, that can't be 4 over pi. That cannot be 4 over pi. No, it's not. Somebody help him out, please. What was the period that we got the first time? Alexander, you have a lot of work to do, and I hope you're going to make sure you find some time to get it done. 2 pi over 3. Thank you very much. So the period was equal to 2 pi over 3. Now this has to be divided by 4. That's a little tricky because we're dealing with fractions here. But we're going to do the same thing we've always done, which is to take the 2 pi over 3 and multiply it by the reciprocal of 4, which is 1 over 4. Okay, that's another way to divide by 4. And that would give us 2 pi over 12 or pi over 6. Okay, so hopefully everybody follows what I just did. I'm going to take some, unfortunately I'm going to have to erase this because this is not going to work. What I'm going to do now is I'm going to take my original x minus pi over 6, right? And I'm going to add on to that pi over 6. So what is the result? Let's help out Alexander on this. So if I have x minus pi over 6 plus pi over 6, what am I really talking about here? What's the result of all of that? Just simply x. Good. So our function should be everything else that we had before, but we actually don't have a phase shift anymore. Okay, we actually don't have a phase shift anymore. So what we had before was 6 cosine. So now that means that y is equal to 6 sine, still pi over, sorry, still 3. So it was 3 before, so it's now 3. And then we don't need a phase shift, just with 3x there. And I think it was minus 1 or plus 1. Why did you change the k? Why did I change the k value? Oh, why did I change the k value? Okay, the k value before was 3. I don't think I changed it. Oh, Alex. Oh, okay, Chris, I'm a little bit puzzled here. Why did you change the k value, Alex? Okay, all right. So can we all agree that it's just simply x then, and that the 3 that was there before is still there, and that the answer would be what we have right now, which is the 3x. Okay. I'm going to put in the center line because the center line can help us out sometimes to get the sine version of this function. I'll put the center line in and I'll show you what that looks like. So it's going to be a dotted line and I'll make it a different color. I'll make it red. So here comes my center line at 1. Not the greatest center line, but anyway, there's a center line. Now, normally a sine function starts off on the center line and goes up. And the phase shift is how far from the y-axis is that? Well, it's actually right on the y-axis. Oh, sorry. It's actually right on the y-axis. That's why there's no phase shift at all. Right? You can't have a phase shift if the starting point is sitting right on the center line, right on the y-axis. That's why there's actually no phase shift. Thought it was wrong getting it. Okay, no, it's not. All right, can we just try to squeeze one more in? I mean, I know we're running up against the clock here. Can we try to squeeze one more in very, very quickly? All right, we won't throw it to the class. We'll just see if we can quickly get it together as a class. Let's try this one, and then we'll leave it there first. What's the a value of this? We'll work on this one together. We won't give you time, just a. The a you're saying is 3 because we're going from 7 down to 1, and from 1 to 7 is a distance of 6. 6 divided by 2 is 3, absolutely. And we're trying to go a cosine function first, so the cosine of. And how about the period of this function? Can anybody comment on the period of this function? We'll get to the k value later on. Period you're saying is 4. Are you talking about the k value or the period? Which one are we talking about here? Is the k value the period? Let's talk about the period first. The c. Oh, you're right. Let's get the other value, the center line. I forgot to do that. You're absolutely right. What's the center line? Let's put this here. You're going to say plus 4. I agree because the c, yes, because 7 plus 1 is 8. 8 divided by 2 is 4. So I agree. Yes, good. Let's get to the stuff inside of the bracket now. Yes, you're right. I should have done the C next. You're absolutely right. I guess because I was rushing, I kind of eliminated some of the steps that we usually do. Let's get to the inside. What's the period of the function? Right? What's the distance from, and I say it again, from one high to the other high? So one high is at 5 pi over 6. We're going to minus from that, excuse me, pi over 3. Okay, so that means that if I put the common denominator as being 6, that's going to be 5 pi minus 2 pi, which would be 3 pi over 6. I believe I got that right. Hopefully I did. All right, so I see somebody saying pi over 8. Well, first of all, can we agree on 3 pi over 6, which is, by the way, pi over 2? All right, can we agree on that? No, is that wrong? Did I do something wrong? Oh, that's okay. All right, so pi over 2 is the period of the function. So my k value, and I know we're going to run out of time here. My k value is 2 pi divided by pi over 2, which is equal to 2 pi multiplied by 2 over pi. Right? Pi's cancel out, folks. There's my k value of 4. Good, Sinuja. Well done. 4. Okay, so I'm going to put 4 here very quickly. And how about the phase shift? And then we're done. What's that phase shift? X minus what? Quickly. For a cosine, that is. What's my phase shift? X minus pi over 3. Good. All right, I'll have to leave it there. Obviously, that question that I thought was so much fun that I was hoping to finish up with, we're not going to get to it. Folks, meet me in block 4, all right? Talk to you later.